Everyone, welcome back to another fun and exciting geometry class. Today we are going to be starting chapter 4. Finally, it seems like these chapters last forever, but we finally made it to chapter 4, and I think that many of you are really going to like this chapter because we actually start doing some math. All right, you're gonna have to use the calculator in this chapter a little bit. So just a little bit of a change from some of the logical progressions that we've been doing. Still a lot of logic here, but it is going to be somewhat mathematical as well. All right, let's look down at page 190. Page 190, 4.1 proportional quantities. Now, before we can really talk about what a proportion is, we have to understand what a ratio is. So go ahead and look down at the screen. And what I've done is I've kind of written all these different words here that are in your book. I've written them on the screen with a little definition, and then I've given myself some space, and I'm going to help you understand by writing some things in so you can pay attention here. Hey, write this stuff down. Don't just say, oh, it's in my book, no problem. Hey, get a piece of paper, get a pencil, get a notebook, whatever, write it down, and that will help you to remember it and learn it. All right, the ratio. What is a ratio? It's been a while. It's been since 8th grade for most of you since we've really talked about this stuff very much. We talked about proportions just a little bit in algebra and algebra 2, but pretty much it's been a while. So let's refresh our memory on what is a ratio. A ratio is a number comparison typically written as fractions, but there's really 3 different ways to write these. If I say the number of boys to girls in the class is 10, because there's 10 boys, to 13, 10 to 13, how could I write that? Well, I could write it as a fraction, so I could write it like this, 10 to 13. We would read this fraction, if we're comparing the numbers, we'd read that fraction bar as the word 2, 10 to 13. You could just put it 10 over 13. It's really just a fraction. Here's another way that you could write it. You can write it 10 to 13. Just write it out, 10 to 13. It's a comparison. This word here is a comparison word. The other way to write it would be 10 with a colon 13. And you're basically saying the same thing except for you're not writing the word 2, 10 to 13. All of these 3 different ways are all valid ways to write ratios. Now, typically and definitely in geometry and most of your math classes, this is the way that you're going to see the comparisons written as fractions. What does that mean? It means that it's a division problem. Okay, it means that it's comparing those 2 numbers using division to make the comparison. All right, next, the antecedent. The antecedent, that is the first term of the ratio, the first term or the numerator. All right, so which one in my 10 to 13 comparison, 10 boys to 13 girls, what is my numerator? Well, the 10 is the numerator. Now look over here. This doesn't have a numerator, but this is the first term in my ratio. Okay? So the antecedent, or the first term, is the numerator. The next idea is called the consequent. Now, it's not consequence. It's a little different. It's consequent. And then the consequent is, and I'll change the color here so you can see this, is the denominator or the second term. Okay, let me pick a different color than the one I used up there. All right, so the denominator or the second term. So what's the denominator? The 13 is the denominator, and the 13 is the second term. So this would be the consequent, and then this would be the antecedent. Okay, so the 10 is the antecedent, the 13 is the consequent. It's important that you understand that, you know that, because now when the book uses those terms, you need to know what the book is talking about. When I say those terms on a video in the future, you should know what I'm talking about. Antecedent and consequent. Proportion. What is a proportion? Well, the proportion is 2 equal ratios. So, in other words, if I have 10 to 13, okay, so there's my ratio. A proportion would say that that is also equal to, let's use 20 to 26. How did I do that? What did I do? I just did it in my mind. It was magic. No. Okay, what did I do? I multiplied that by 2, and I multiplied that by 2. Remember, you can always multiply or reduce any fraction that you have. This one, you can't reduce it. There's no common factor there, so I went up to the next one. I mean, I could make this 100 over 130. And that one I just multiplied by 10. And I got 100 over 130. These are all, notice the equal signs. They're all equivalent ratios. So let's go back to this one. Let's go back to the first one that I did. All right, so there's my equivalent ratio. Now, I want you to see something. And this is super, super important for the next few lessons for you to understand. The next two things that we're going to talk about is the extremes, okay? And those are the first and fourth terms of the proportion. So let's kind of think of it this way. Here's the first term. This is the second term. This is the third term. And this is the fourth term, okay? 1, 2, 3, 4. Now, what it says is the extremes are the first and the fourth. Okay, the first and the fourth. Or they are the outsides. They're the kind of like if you start with the first and then you end with the last. They're the outside terms. Okay? So that is the extremes. I'll use that pink color on the extremes. The means are the second and third terms of the proportion. So the second was the 13 and the third was the 20th. Okay? So remember, first, second, third, fourth. First, second, third, fourth. Okay? Now there's something very interesting about the means and the extremes. Because of this equal sign right here in the middle, okay? So because of that right there in the middle, the means always equal the extremes. I didn't write that down, but I'm going to write it here. The means always, and that's an important word right there. Usually, sometimes, or yeah, we've had those always, sometimes, never questions on quizzes and things. It's important that it's always. This is always true. This is a law of mathematics. The means always equals the extremes. There we go. The means always equal the extremes. What does that mean? Okay, what does that mean? You see what I did there? What does that mean? All right, here's what it means. You're not laughing at my joke. I'm sorry. All right, I'll move on. Don't worry about it. All right, so what does it mean? If we multiply our means and if I multiply our means times our extremes, they're going to equal each other. Let's do it. Let's check it out. So the yellow 2, that's the means. That's 13 times 20 is supposed to equal what? The green ones, 10 times 26. Okay, so let's do it. All right, 13 times 20, what does that equal? Well, that equals 13, 20, that equals 260. 260. And then that equals, what's 10 times 26? 260. This is the way that you can verify whether or not, it's like checking your answer. You can say, oh yes, I did get the right answer because my means equaled my extremes. Okay, so it's always going to work out. If it doesn't work out, if the means don't equal the extremes, guess what? You don't have a proportion. Your fractions are not proportional to each other. Proportional means that the means equals the extremes every time. All right, a couple interesting things here, and then we'll be done with this lesson. The first thing is the idea of what's called fourth proportional. If something is fourth proportional, that means that we're missing the fourth. We're looking for the fourth. So, for example, if I have 1 over 2 equals 3 over x, this one is what's called fourth proportional. Why? Because we're missing the x. We're missing the fourth term. When there's something to find, you call it fourth proportional. Okay? So in other words, we're looking for the fourth term. We're looking for the missing term. So if we have 3 terms and we're missing 1, it's called fourth proportional. Okay? And typically, you're going to put it in the 4th spot, but you don't have to put it in the 4th spot. You can put it wherever you want to, but it's fourth proportional. How do you figure these out? How do you solve these? How do you solve fourth proportional problems? Well, you do the means. There it is. 2 times 3 equals the extremes. 1 times x. 2 times 3 is 6. 1 times x is x. 6 equals x. So our answer, our missing fourth proportional, is 6. So to complete out our missing number, to find our missing number, just do means times the extreme, or means equals the extremes, and you will get the right answer. Well, if you do your math right, you'll get the right answer. All right. Mean proportional. What does this mean? What does mean proportional mean? Here's what it means. Any proportion in which the 2 mean terms are equal. All right, so what does that look like? 2 over 5 equals 5 over x. Okay, this is what's called mean proportional. Why is it mean proportional? Because the means are equal. Okay, and this one's it's going to be a little bit hard to do. It won't be too bad, but we'll get a decimal number for this one, which is fine. So here's what we do. We just multiply our means times the extremes. So we get 2x equals 25. We divide both sides by 2, and we get x equals, what is that, 12.5. 12.5. And so this is called mean proportional, when the means equal each other. So 5 equals 5. That is called mean proportional. Now there's something else about mean proportional. Notice when it says third proportional. Third proportional. So we've already done fourth proportional, right? Fourth proportional meant that we were missing a fourth. So this problem up here that I gave you where the 5s are equal, here's what it's saying. It's like saying, let's call this A over B equals C over D. I think this will help you understand it. Well, notice that B equals 5 and C equals 5. Now, what can we say there? We could substitute, couldn't we? Yeah, we could say that B and C are equal, so we'll call this B and we'll call this C. Notice that the means are equal. 5 equals 5, B equals B. Look what happened to our D. Our D went away. So it's not fourth proportional, it's third proportional. Why is it third proportional? Because there's only 3 parts to this proportion, because the B's equal each other. So you have A equals 2, B equals 5, and now we would say that our C equals, and that's our 12.5 that we figured out. All right, so this is what's called third proportional. Why? Because A is 2, B is 5, but B is showing up in 2 places, okay? And C. So you only have 3 answers. Look here. I have an A answer, a B answer, and a C answer. That's only 3 answers. So that's why they call it third proportional instead of fourth proportional, because I only have 3 answers technically. All right, well, that's all I have for you today. I hope you learned something. Lots of stuff there to kind of take in. Somewhat confusing in certain parts, especially there when it gets down to the end, but hopefully you can keep that straight with the fourth proportional, mean proportional, and third proportional, how that all works together. Make sure that you remember the means equals the extremes. If you missed anything there, slide it back. Make sure you review it because these next few lessons, you're going to be using all of this stuff a lot to solve these problems, okay? All right, we'll see you later. Have a good one. Bye-bye.